Hello, sixth graders. Mrs. Parsons here, still at West Platte Elementary School in sixth grade mathematics. And today is October the 28th, 2020, and we are working with Lesson 5, Session 2 in our math book. And it's going to talk about writing and evaluating algebraic expressions using exponents. Now, before I go any further, I'm going to let you know, I don't know how long this video is going to be. And I tell you that up front because there's a lot I want to cover in this video to make sure of a couple things for you. One, that you truly understand algebra. Two, that you really know what an exponent is. And three, that you know how those things can work together. So for us, I'm not really worried about what lesson we're at in the math book. What I'm worried about is, do we understand the math that we're talking about? Do you know what algebra is? Do you know what it looks like? Do you know how it works? Do you know how to use it? And now we're going to move forward, sixth graders, and we're going to ask, do you know how to use algebra when it involves exponents in some algebraic expressions? So I want to take a step back, and I've made a slide for every one of these examples because I think I need to go back, or I'm going to go back. Maybe you don't think I need to, but I'm going to go back to the very beginning of thinking about expressions and how we have gotten to this point where we think about expressions to algebraic expressions with exponents. I want to go through some of the stuff that you've already done in your life so that you can see how it comes together in the sixth grade. And you're like, oh, boom, now I see. I knew that, and it works with this. Oh, I knew that, and it works with this. I want to take a step back, and I want to talk about each of these things. Now, I don't know, as I said, how long the video is going to be, but I know everything in the video is important. So I'm going to step back. Again, I'm going to tell you it's October 28, 2020. We're working in our math book. I'm not worried about the lesson in the session. What I'm worried about is, will you understand when we're done talking this week how to write and evaluate algebraic expressions with exponents? So I want to start off right from the very beginning and say, sixth graders, this won't happen if you don't remember some of the things that you've already been taught or that you have already learned. And I want to tell you the two things that are very important that you've already learned while you were in school. One, last year, you talked about powers of 10. In a moment, I'm going to show you how that means an exponent. Powers of 10 are exponents, and I'm going to show you how that works. Second, in the sixth grade already, we've talked about solving algebraic expressions. So if you are having trouble still understanding those two things, I'm going to let you know in honesty, you're going to have trouble with writing and evaluating algebraic expressions with exponents. So if you're having trouble with these two things and you can't remember how they work, reach out. Reach out. Does that look like a good video? Like I should do like, I don't know, some TikTok video with that? Reach out. Sixth graders, if you're having trouble with these things, you need to reach out to your teacher, to someone to ask those questions and say, please, please, please help me. I don't understand this. Because the more we go on, I feel like I should do a stair step. The further we go, sixth graders, the harder it gets. The more we move forward, if you don't understand something that we've already talked about, the harder it gets for you to move forward. So if you don't understand the things that we're learning in class, reach out and ask questions so that we can help you figure it out. So if you're having trouble with powers of 10s and solving algebraic expressions, I've got the video for you today. I'm going to start way back, way back when you first came into school. I'm going to skip grade K. And I'm going to go right to first grade, which just probably isn't first grade, but it was like first, second, third grade, okay? When you came to school in the first, second, third grade, you did math. You actually worked at solving mathematics. And one of your teachers, I'm going to think it was your second or third grade teacher probably, gave you a problem that looked like the one Mrs. P has on the board. 52 plus 41 equals 93. And you're like, oh, how does that work? And she showed you something like 52 stars. I'm not going to make 52, but you get the idea. She made 52 stars, and she said to you, I want to add those stars to 41 more stars. And she said, how many stars do you have altogether? And you either did one of two things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. You counted them all individually, or you learned how to add these things. And you said 52 plus 41, and you added them up because you like writing problems vertically instead of horizontally. And so then this was easier for you to see, oh, 2 plus 1. I have $1, $2. Mrs. P gives me another $1. How many dollars do I have in all? Well, I have $3. Then I said I have $5, and I'm going to give you $4 more. How many dollars do you have in all? You said 9. And that's the way your teacher showed you how to use addition. Putting individual pieces together, which are known as wholes, whole numbers. She showed you how to model it and draw it out, or how to do an algorithm to solve it, because you knew how to add numbers. That was second, third grade. Well, as you moved on then, sixth graders, sometimes you got to a teacher who said a problem to you as, well, 52 plus gives me 93. And you're like, what? What's that? What goes there? And hopefully, fingers crossed for Mrs. P, your teacher told you a way that you could figure out 52 plus blank gives you 93. And I hope that by now, you know if you're adding, if you want to check your work or find a missing answer, you can do the opposite operation, such as subtraction. That's called the inverse operation. And it means if you want to find something out, use the opposite operation to solve it. So right now, if I gave you the number to put in there, you would just say 52 plus blank equals 93. But since that blank is there, you do not know what plus 52 equals 93. Well, instead of using addition, I can solve this problem by using subtraction. And what that means is I'm going to take away this 52. If I have $52 and I take away $52, I have $0. So now there's nothing left over here except this blank. Well, remember, in mathematics, it's a scale. And if you do something to one side of math, you better do it to the other or you're off balance. So you've got to do the same to each side so it stays in balance. That's how you know if math's really working. So if I subtracted 52 from this side, I'm going to come over and subtract 52 from this side, and I'm going to see what response or what solution I get. 3 minus 2 is 1, and 9 minus 5 is 4. So it tells me that that blank should be 41. Well, let's check. If I have 52 plus 41, does it equal 93? And all I did was take that number that I found, and I put it back into my problem where my blank was. And that allows me to check my work. So then I go 52 plus 41. Yep, it's 93. Now you started doing that again in second or third grade. Well, now you've come to Mrs. Parsons. And I've turned this problem into this. 52 plus B equals 93. And you're looking at me going, what in the world is B? Nobody knows what B is. But the fact is, sixth graders, you do know what B is. You can solve B because, sixth graders, you have used this mathematics before. You know how to add, subtract, multiply, and divide. So all you have to do is use those basic math operations to solve what this letter is, which we now call a variable. We've now went from numerical problems, that's this, numerical problems, to algebraic problems, which means we took out one of the numbers and we placed it with a variable, and we ask you, hey, what does that variable mean? What is that variable? Can you figure it out? And you can just by using your basic math operations. Just because I put B there doesn't mean you can't answer it. You can look at this problem just like you did this one, which you learned back in 2nd and 3rd grade. If a number's missing, can I figure out what's missing by using different math, which means use inverse, the opposite. So in this case, I've got 52 plus B equals 93. I'm going to do the same thing. I'm going to minus 52 because now that leaves me with nothing. $52. I spend $52. I've got no dollars left. So now the only thing left over here is B, but I still don't know what B is equal to. B is not equal to 93. And if I wrote that, 6th graders, I should know I'd be wrong. Because if I didn't put it back in, if I put 93 where B is at, would 52 plus 93 give me 93? No bueno. So you know that's not good. So you have to figure out what B is. And the easy way to do that is inverse operations. You subtracted 52 from this side. So now you're going to subtract 52 from this side. And when you subtract 52 from 93, you get 41. And that is what B equals. Again, I go back up and I put 41 in for B. This is what we've been doing in 6th grade. Algebra. It's now an algebraic expression because it's got a variable in it, a letter. But that really is no different, 6th graders, than what you started doing when you came to school in 2nd and 3rd grade. You did a nice, easy problem. All the numbers were present. Then your teacher took a number away and said, what's that missing number? And you said, how can I figure that out? Now, the part I think we're missing is the You've got to take a moment to say, how will I figure that out? We've got to use that reasoning to see if we can solve these problems. So you went, and you figured out that that missing number was 41. Well, now here you are with algebra. It's the same thing. You have to go, how am I going to figure out what B is? If I've got 52 on this side, and 52 is going to be added to something, and in the end, I'm going to have 93, what did I do to get B so that 52 plus that equaled 93? Well, take away the 52, take away the 52, and now it tells you B is equal to 41. That's algebra. So you went from numerical expressions to algebraic expressions. Now, once we're done with these 6th graders in the 6th grade with algebraic expressions, we're now going to add exponents into those problems. But don't get scared and worried. Again, it's working on stuff you already know that you already learned 5th grade, and you're going to apply it to what you've learned now in 6th grade, and you're going to put those two things together so that it'll work for you in mathematics. But I want to take a step back, and I want to talk about the exponents. Before I even do that, I'm going to do that. I'm going to talk about the exponents first. So in the 5th grade, 6th graders, you talked about these things. This is known as the power of 10. And what you were taught is a good thing, but you need to build upon it. When you were in the 5th grade, I'm going to think you were taught that this is the power of 10, which you were told that just means you could add 5 zeros onto the 10. So you go 1, 2, 3, 4, 5. And that is your answer, that 10 to the 5th power equals 100,000. Now, I want to break it down to you just a little bit further than that and truly explain to you what is a power and what does it mean to use an exponent. Not just powers of 10 use exponents. Exponents are used all the time with different numbers. And it's really to make life easier on you, to make it shorter in your math problem so you don't have to write as much work. So what we should be telling you 6th graders is that powers that use exponents have certain roles. They have certain jobs. So last year when you learned this in the 5th grade, what 10 to the 5th power really means is not just add 5 zeros. What it really means is that number right there is called the base number. It's the number you're using. This is the exponent, and it means how many times you're going to use that base number. That is what a power is. You have a base. The exponent tells you how many times are you going to use that base in your multiplication problem. So in this case, sixth graders, 10 to the fifth power really means 10 times 10 times 10 times 10 times 10. It really means multiplying 10 by itself 5 times. And after you get done multiplying that, sixth graders, you should get this answer of 100,000. And if you notice, 1, 2, 3, 4, 5, there are 5 zeros. But if you don't understand how this really works, all you ever want to do is add zeros. And that doesn't work that way. That's not correct. So what you're really doing is taking that number, called its base, and you're multiplying it by itself that many times. And if I did that right now with this number, 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 100,000. Or no, 10,000. Sorry, skipped one. Is 10,000. 10,000 times 10 is 100,000. And that's the work we should be doing with powers that use exponents. And if you look back, sixth graders, then you say there's 1, 2 tens. I use those to get 100. There's the third 10. It's right there. There's the fourth 10. It's right there. There's the fifth 10. It's right there. And that is how I got 100,000. It wasn't that I just added 5 zeros. Yes, you can do that, but only if that base number is a 10. It's not always going to be a 10. It could be any other number, such as this. It could be 9 to the fourth power, sixth graders. And this answer is not 90,000. That is, oops, it's in yellow. Let me do it in a dark color. That answer right there is not 90,000. This answer means you take the base, and in this case, the base is 9, and you use the exponent to multiply that base that many times by itself. So the exponent is 4, so I need to see 4 nines. I need to multiply 9 times 9 times 9 times 9 to get the answer. And I can tell you right now, it's not 90,000. And if you continue to do that kind of work, you're going to get it wrong and you're going to be very unhappy. What an exponent does is tell you to the power of 9 to the power of 4. So you take 9 4 times because the 9 has 1 power, 2 powers, 3 powers, 4 powers. So it means it's got 1, 2, 3, 4 powers. So you need 4 nines to find out what that answer is. And then you multiply it out. 9 times 9 is 81. Well, this 9 times 9 is 81. Now I just need to multiply 81 times 81. And 81 times 81, Mrs. P is going to multiply this out really quick for us. Add my placeholder. And the answer, sixth graders, is really 6,561. 6,561. Is that the same as 90,000? No way! And if you answer something like that, you're going to get it wrong and you're going to be upset. So you really have to understand how exponents work. Why? Because that's what we're going to start doing now. We're going to put these exponents, these powers, inside the algebraic expressions that you've already learned. So we're going to start doing things, ladies and gentlemen, like this. I'm going to start back. Here's what we did. 52m plus 18. Now we're going to move it to 52m plus 6 squared. And then eventually we're going to make it to 52m plus x squared. It just keeps getting bigger and bigger. Now, I could use this word instead. It just keeps getting harder and harder and harder. I don't want to use that word for you. It's not getting harder and harder. I'm going to tell you every time that the math keeps getting bigger and bigger and bigger and more advanced, you can do it based on stuff you already know, sixth graders. So let's go back and see if we can do this. If I started off with 52m plus 18, the other day I told you the only way you can solve this algebraic problem is only one of two ways. Somebody tells you what m equals, or they give you the solution. So I'm going to say I'm going to make it easy. I'm going to say m is 1. So what does that mean? It means you put 1 where m goes, or where m is at. So now this is going to say 52 times 1 plus 18, and you can now answer that problem. Because you know a number by a letter now in algebra means to multiply. So somebody told you m was 1. 52 times 1 is 52, and 52 plus 18, ladies and gentlemen, is 70. So you could solve that problem. That's one way. The only other way is if somebody gave you the answer. So I'm going to erase this, and I'm going to erase this, and I'm going to erase this part, if I can get it to come down here. And I'm going to say, oh, sixth graders, the answer is 70. And you're going to have to figure out how you answered that problem. They didn't give you m, so you have to think about what times 52 plus 18 would give me 70. Now, this is an easy one, so you're going to be looking at it right now, and you're going to say, oh, well, 52 times 1 gives me 70, because 52 times 1 is 52, plus 18 is 70. But if you didn't know that, sixth graders, you're going to have to do some work to solve that. Again, here's where you have to remember your inverse operations. I want to find out what m is. That's my big goal. What does m equal? Well, anytime I'm trying to find out a variable, what I need to do is I need to get rid of anything that's with m. Well, I see the first thing that's with m is 18, and I want to get a new color here. So I want to get rid of this 18. How do I get rid of 18? I just don't kick it to the curb. I got to do something with it in math. So I'm going to take away that 18, because right here it's a good $18. And if I want to get rid of my $18, one way you can do that is go spend your $18. Well, if you spend it, that means you took it away. So then I take it away. Now, it's not here any longer. The only thing that's left over here now is 52m. And if I take 18 from this side, I have to take 18 from this side. And if I take 18 from 70, sixth graders, I have 52. And I look at that now, what times m is going to give me 52? Or 52, what times 52 is going to give me 52? Well, in this case, 52 will only go into 52 one time, so m must equal 1. These are the things we're doing, but now we're just going to keep building upon them. Can we solve this problem? Yes, using inverse operations. Can we then turn it into, ladies and gentlemen, one that has exponents in it? Well, let's see if we can. Let's just try this. Let's say m this time is equal to 2. Remember, the only way you can solve this, if they give you an answer out here, or if they tell you what m is. Well, here they told me m is 2. So let's fill it in. Let's do substitution. 52 times 2 plus 6 squared equals. Okay. Well, I can do 52 times 2. 52 times 2, that's 4. And 2 times 5 is 10. So this equals 104. Now I just need to figure out, what does this 6 squared mean? Well, sixth graders, 6 squared Doesn't mean adding zeros. It means 6 times 6. And hopefully you know, and I'm going to scoot this down, hopefully you know 6 times 6 is 36. So now I have 104 plus 36, which must mean my answer is 140. And that is what we're working on, sixth graders. We're taking that algebra and we're adding those exponents. But you've done both of those things already. You've done exponents. You used them as powers of 10 in the 5th grade. You've done algebra already with Mrs. Parsons. So all you're doing is putting these two things together and doing the work for them. And I really want to make sure you understand that, because that's going to be your homework all this week. That's what we're working on all this week. And eventually, 6th graders, we take this and we turn it into the very last one right here. Oh my goodness, Mrs. P, what are you talking about? There's an M and an X. But 6th graders, if I told you what the M and the X were, could you solve this problem? Let's see. I'm going to say M this time equals 3. And I'm going to say that X equals 5. The first thing you're going to do is rewrite the problem, putting the variable into its spot. So you're going to say 52 times M is 3 plus X is 5, 5 squared. And then you're just going to work out that multiplication. 52 times 3 is 156. 5 squared means 5 times 5, which is 25. And that answer, 6th graders, is 181. And that is solving algebra with exponents. That's taking your prior knowledge of how to add things, how to use inverse operations, and apply it to powers and exponents. Apply it to algebraic expressions, and now put all those things together with algebraic expressions and exponents, and then solve what you know. 6th graders, you can do this. Just take a step back. Think about what you have learned, what you've kept up here, and work those problems out. Now, once you do this, 6th graders, you now know how to solve these exponents. You're going to be having to be working with how to write them as well. So real quick and easy, if I asked you to write this as an exponent, you should be able to say, oh, you want me to write that as an exponent? There's 5 of them. It's 7 to the 5th power. That's easy enough. If I said, hey, 6th graders, write that out as its exponent, you've wrote it out. So you can take it from all the numbers and turn it into an exponent, and take it from an exponent and write it out as all its numbers. So I know the video is 30 minutes long, but I really think you need to hear all the things that are in this 30-minute video, because this is what we're working on all week. And guess what? Once we leave this, then it gets added to something else. And you want to make sure every step of the way you're picking up each little thing that we're doing in mathematics, so that you can build it, until someday you're like, I made it to my senior year and I'm graduating. I know everything about math that I need to know to get out of this place. Hopefully not too soon. Don't rush your life away. But anyway, that's the video for today, talking about evaluating and writing those exponents. So please watch the video all the way through and let me know if you have any questions. Otherwise, I'll see you back on Thursday, which will be October the 29th. And I just hope you have a wonderful, wacky Wednesday. Until Thursday, 6th graders, have a great day.